Hi, so today we're going to be going over a board from one of my favorite customers. So there are people who send stuff here that try to do their own board repair and fail, and this is something that I'm going to be putting an end to very soon. So the way my system works is it's no fix, no pay. So if I cannot fix a board, you don't pay. Also, it is a flat rate regardless of the problem. Now, obviously, if you have problems that are absolutely miserable, this would benefit you because the rate doesn't change. And this is somebody where every single board is a nightmare, and I usually repay the favor by just sitting on them as long as possible while doing the ones from people who didn't destroy them. So to give you an idea in the microscope, why this is gonna be a nightmare. So first, you start off with the let's see, the PP5VS3 circuitry over here. You can see all of that is red and nasty and blah. So we're gonna probably see some issues there. As usual, you know, it has where the 12-volt line comes into the chip, that it looks like it's burned. You can see from the red probe point and what that looks like on that capacitor that that's maybe going to be bad. You can see over here right by the CPU V-core circuitry, so you have those two CPU IMVP ton resistors. I talked about this in 2 other videos. Those are going to be a complete another nightmare. Those are probably going to be gone, and you can see there's red all around the chip. So with luck, it'll just be those 2 resistors. With bad luck, it won't be just that. You can see by the backlight area of the chip, so let's just refocus a little bit here, that it is corroded. The enable resistors are corroded. You're going to see that the chip itself has large red indentations around where backlight is, and you're going to also see that the LCD connector itself doesn't look really that great. And in addition to that, we also have no power on this one, because there is a short. So let me just show you what's going on with that. So I love that I can set up transitions in this program in real time. It totally keeps me from having to edit junk out later and having to move stuff around, and I'm not screwing with that anymore. I love open broadcast software. I actually donated $100 to this right after I used it because it was so useful. So you're going to see over here that I said over here, zoink. Okay. Now I'm going to try measuring on, let's just get some ideas of what's going on here. So I plug in the charger. Got no green light. I have no light at all. Let's check for voltage. So I'm going to check on the inductor for PP3V42 and the output of that supply, and I get nothing. I'm going to check on the F7040 for the main 12-volt rail of the machine, and I get 0.8. So yeah, there's pretty much nothing going on here. So let's see on the power supply that has 0 volts. I'm going to check for a short by turning this into diode mode. And I'm going to put my red probe here on ground, and I'm going to put my black probe here on the inductor for PP3V42. And that is measuring voltage drop. So between ground and the output of my power supply, I have a voltage drop of 0.001 volts, which means that there's a short to ground on that line. Now, it's actually on both sides of that inductor. So what I'm going to do to try to figure out what's going on here, I want to see what side of the inductor that short is on so I know what to chase. I'm going to remove the inductor. Now, just to give you an idea what's going on, before I wind up, while I'm waiting for my iron to get hot there, I'm just going to open the schematic, and I'm going to give you a little bit of an idea of what it is I'm doing and how it is I came to the conclusion that I came to. So let's go here to the screen capture, and let's get that in full screen for a moment. I love open broadcaster software. No editing necessary. This is going to be literally, this is going to be from start to finish. Everything is done. So you can see I have Tori Amos on my desktop here, one of my favorite singers. And so I'm going to open the schematic here. Let's open. Okay, so you guys may be wondering, where do I find out what power supplies I need? You guys also may be wondering where I get the schematics from. Hint, please stop asking when it's right over here. Let's scroll down. And, oh, that's some slow scroll this Adobe has. All right, let's try this. So, functional test points, blah, boring. Here we go. So you're going to get a page like this somewhere where it's going to say always present rails and all these other rails, and it starts with the important ones and goes down. So PP bus G3 hot, we measured that and there's 0, but there's no short to ground there. PPVIN T29, I'm not interested in Thunderbolt right now. This is 12.8. It's a derivative of this, which is 12.8 from PP bus G3 hot. PP18V5 DC in connector. Not it. Obviously, if anything here is getting any power, the DC in rail has something on it. PP3V42. So this is the one that I checked for a short. Admittedly, I didn't check 18.5 volts for a short yet, because I know that 99% of the time that's not shorted, just from experience. So my iron should probably be hot now. So I'm going to turn on my air filter, my air purifier fume extraction thing, and we're going to get started on that. So first things first, let's go back over to the microscope. We're going to remove that little inductor, and then we're going to try to measure what we get on the multimeter on both sides. So, the other thing I'm going to... Actually, did I ever show you what I was actually removing on this? No, I didn't. That's kind of mean. Okay, so let's go to the PP3V42 power supply. The 3.45 volt G3 hot power supply. So what this does, as I explained in another video on what this power supply does, this is input from the charger right over here. So this PP18V5, that's the charger. Now over here, this is the input from PP bus G3 hot. So the way this works is this entire system can actually be powered off of the 12 volt rail that the charger creates, but this rail needs to be running before you have a charger. So the one-wire circuit, which I've talked about in another video, which I'll link to in the annotation here, the one-wire circuit has to be running in order for everything else to actually start working. And the one-wire circuit runs off of PP3V42_G3 hot. So this has to get working before everything else. So even if you don't have PP bus G3 hot yet, you have to have this power supply. So this power supply works independently of PP bus G3 hot when you're plugging the charger in. However, if you're running off of battery, this power supply will be created off of PP bus G3 hot. Now PP bus G3 hot is not always there if the battery is dead. So that's pretty much why you have this system over here. I'm doing a terrible job of explaining it. Long story short, this is the only power supply in the machine that has two different inputs. Every other power supply in the machine has an input coming from one power rail. This is a power supply that can actually have an input voltage from PP bus G3 hot of 12.6 volts or an input voltage of 18.5 volts from the charger. So that's this over here. This is the chip that makes 3.42 volts out of either 12.8 or 18.5. This over here is an inductor. This inductor is going to take a bunch of pulses of 12 volts or pulses of 18 volts, and it's going to turn it after this capacitor and this inductor into a nice flat 3 volts, 3.4 volts. Now I don't have 3.4 volts over here, I have 0, and I also have a short to ground on both sides of this inductor. So the short could be on this side, in this section of the circuit, or it could be on the system side of the circuit. And the only way to tell and get an idea is to actually take that off. So yeah, a lot of people ask why I don't do classes on basic electronics. I know what I'm talking about. I know I have it in my brain. It's just I'm so bad at explaining it that I feel like I'm kind of doing a disservice to you. So I mean, explaining the practical aspects of this, I feel I can do and I'm qualified for. Explaining how the circuit actually works and all this, I honestly, I know what I'm talking about. But when I actually start getting the words out of my mouth, I mess up so terribly bad that it's a joke. So yeah, somebody asked why I don't do a video on basic electronics. I don't want to do a disservice to electronics by butchering the theories with my videos. Because people think it's easy to be a professor. It's easy to teach this stuff. Teaching isn't hard. It's a pain in the ass. It's not it's easy to know something. It's really, really hard to actually teach it. Because you may understand something, but when you actually start putting it into words, you'll notice that it isn't as easy as you think it is. Okay, so we've removed the inductor. By the way, if you're wondering how I found that inductor, you probably haven't watched any of my other videos where we use this board view software over here. Let me just show you that real quick. So this is terrible software. But it does the job. So let's see on the PDF reader. It says that that's L6995. That is L6995. So once I open the appropriate board in the board view, I can hit C, type L6995, and it brings me right over here where I can see it up close and I know what it is. So this is going to be the side where it's making the power supply, and this is going to be the side where it's sending it to the system. So now that I have that information, I can go back, okay, and do my measuring. So now let's see if which side the short is on. So I got my red probe on ground. I'm going to put the black probe on the side where the power supply is being made. And I have OL. That means that there's no path at all. And then I put it over here. And I have 0.01, which means that the short to ground is on the system side. Now, the way that I'm going to find where that short is, pretty simple. What I'm going to do is I'm going to attach one of the wires from my power supply to the 3-volt system side. So when I say system side versus power supply side, the way this works is this is the side where the power supply chip is sending the power to the inductor, right? Now, the combination of an inductor and a capacitor are going to take that and they're going to smooth all those pulses into 3.4 volts. That's this side. And this leads to the system. So everything on the system that's powered off of the 3.4 volt rail, this is where the 3.4 volts is flowing. So what I'm going to do is there's supposed to be 3.4 volts there. There's not 3.4 volts because at some point in the system that is being shorted to ground. So what I'm going to do is I'm going to put 3.4 volts of my own on the 3.4 volt side of the system from another power supply. So I'm going to solder a wire right now from my power supply. Let me just take a wire and strip it to get it all ready. It doesn't have to be pretty because it's not like it's going to stay there permanently. Just okay, so that's a wire from my power supply. Then I'm going to take the ground wire of my power supply and I'm going to attach it to the ground of this board. So keep this in mind. The ground of this motherboard, for some reason, is tied to the 3.4 volt power supply. So I'm going to tie the ground of my power supply to the ground of the board. So the 3.42 volts that I'm injecting is going to get sent to the ground of my power supply. It's going to have a path to it through the component that is causing the short. So whatever component died and is short-circuited to ground is going to have all the power from my power supply go through it, which is going to cause it to get really hot and maybe smoke, and that is going to allow me to figure out what's wrong here. So I'm going to see if I can, without driving myself nuts, if I can give you a view of my power supply. Because I honestly don't feel like moving my camcorder right now since the wires, I finally got the wires to a point where it's not a cluster and a mess. And I'd like to try to keep it that way. Okay, rest in peace, clean office. So, what I'm going to do now is I'm going to turn my power supply on. This is an Hewlett-Packard 6542A. I'm confident this power supply is probably older than I am. And what we're going to do here is I'm going to set the current to the maximum current that this thing can put out, which is 10.234, I believe, 10.238. And then I'm going to put the voltage to 3.42 volts, which is the maximum that that part of the circuit can use. You probably cannot see any of that, so I may be editing it so that the lighting is a little better. All right. Then I'm going to turn it on. Now it's showing me that it's putting 0.67 amps in. Now it's putting 0.4. So the way you get how much wattage it's actually putting in, you could do 3.4 times 0.4. It's putting about a watt and a half in. Not a lot. But whatever is actually, whatever is shorted to ground is going to start getting warm. Not very warm because we're at a low voltage and a low amperage. And it actually keeps going down as we go. So what I'm going to do right now is I'm going to feel around the motherboard with my hand until I burn myself. This is always fun. Just move the microscope out of the way. This is also a part of why I kind of laugh at that whole anti-static thing for these types of repairs. That whole general idea of, you know, like really caring about ESD safe workplaces. I mean, Like my diagnostic procedure for a board is to hook wires to it and send maximum amperage through whatever component is shorting the board to ground. So I mean, I'm burning pieces of your board to figure out what's wrong with it. Like static. Static is the least you got to worry about if you're sending something to me. Let me tell you. So over here we're a little warm. Okay, somewhere over here we're actually kind of, ow. So now it's going to be in that area that we're looking. Now that I've already given you an idea of how that little power supply works, I can put my camcorder back where it belongs and unscrew my wiring setup in my office. But every time I wind up dragging this camcorder around the wires So what I like to do at this point is put a little bit of alcohol on the board in the section that is messed up, and then see what evaporates first, what kind of sizzles. So as alcohol evaporates quickly, but particularly with heat, it's going to evaporate fast. So I want to see what is it that I think is causing this. Just pouring a little bit of alcohol, and also alcohol is not going to harm the board if I pour it. You can buy a FLIR cam. One of the things you're going to see if you buy a FLIR cam is that you're going to spend about $700 on something or $1,000 or $6,000 on something that does the exact same thing that I'm doing right now for about 10 cents for the cost of the Q-tip and a little bit of alcohol that I used. So it doesn't really make much sense to me. Again, a lot of people disagree with me on tools. Because there are times where I think spending money is really, really important. There are times where people claim that I'm a cheapskate. I will spend money on tools that allow me to do my job faster, better, that will bring me more money. And I tried this one like $1,500 FLIR cam, and it's like the resolution on it. It's so bad that I'm literally better off using alcohol and waiting for it to fade away. Even when you buy the $6,000 one, you're better off just watching the alcohol fade away than you are in the. So what I'm doing now on my board view on the screen is I'm putting PP3V42G3 hot up in that area. I want to see every component that has PP3V42G3 hot running through it so I can get a little bit of a better idea of what exactly is causing it. And I think at this point we can all agree that this is what is doing it. Because now if I look on the board view, let me just show you the board view for a second here. You're going to see, God, this software sucks. Yeah, so this chip on pin 1, this is what we're looking at. Ignore the fact that these legs are not showing up for the chip. This is it. It's just this software is garbage. Right over here, this leg is PP3V42. Now, this chip is probably going to have a path to ground on one of these legs. Here we go. So that pin is ground. So probably inside this chip, pin 1 and pin 8 are shorted. So we're going to confirm that theory by removing the chip, and then I'm going to look over at my power supply and see if it's still delivering current. So one of the cool things about this power supply is it tells you how much current it's delivering at any given time. So if I remove that IC and then there's no current flowing when I turn it on, that means that this was the cause of the short. Also, one of the things to be careful of in this point, the other side of the board uses through-hole RAM slots. This side uses BGA RAM slots, so it's real easy to fuck them up. So when you're doing work like this, you want to make sure that you actually remove the memory from the computer. Also, you want to make sure that when you're done soldering, you actually wait a good 10, 15 seconds for it to cool off, because you don't want those BGA pads coming up and you don't want any of that stuff getting damaged. Or then you're going to be in a situation where they have less RAM than they did before, and they're going to bitch about it unless you put the RAM in there. Unless they're one of those people that has 16 gigs of RAM, in which case they are stuck with 8, and then it's just nasty. You don't want to deal with that. So now when I turn my power supply on, I have 0.001 amps flowing through, which means that my short is gone. So it was indeed that chip that was bad, so we're going to replace it now, and that will have solved one problem with this board. But as I showed you, just based on how this thing looked, I know that I'm going to have more issues with it than just that. This client in particular, he never sends anything where there's one problem. It's like there's always 2 or 4 or 10 or... Again, these boards sit in the bottom of the pile because I know that they're going to be a nightmare, and I know that I'm going to be spending hours on one job. Like when you count, you have to consider your time worth something when you get to this level. I'm not saying that I'm a genius by any means, but I mean, once you have a desk, you know, and thousands of dollars of inspection equipment and thousands of dollars of microscope, you know, and thousands of dollars of rework equipment and all that, your time, it has to be considered worth something. So when you put in what it costs for me to sit here and work on it and the amount of time I wind up spending on it, in total, the job winds up coming out to be minimum wage. About that when I work on this particular person's stuff. If you had the hand control that I did, you would not find this job fun. I still find it fun. But that part I don't. You don't want to get too much solder on the center pad. It's just supposed to be a heatsink pad. Nothing special. Okay, we're going to take a chip from another board and put it on this one. Looks terrible. Beep. Come on, beep. Excellent, you've beeped. Okay. Move that thing into place and we'll be done. No wonder my heat was turned too low. That's why it wasn't actually melting anything. I really think it's time for me to get a new heating element for my FR801. This thing's been going for like 6-7 years now, about. Turned almost all the way up and I can't melt a damn thing anymore. Jesus. Come on. Finally. Yeah, this thing doesn't blow the way it used to. There we go. This thing damn near 3 minutes to get hot. I have to add calling Hacko to my list of annoying tasks to do tomorrow. Oh, wrong tip, wrong tip. They clean the sides. I know there are people who are going to troll because I like Hacko and go, look, your iron's not getting hot, blah. Yeah. Can you say that you used yours for 7 years for 5 to 9 hours a day every day and that yours didn't die? I don't think so. So no, your troll is not valid. Okay, let's see if my short is still there. I'm going to turn on the power supply and short is gone even though the chip is there. So now it's going to be time to put the inductor back on. So let's get rid of our jerry-rigged short detection system here. And move on to other parts of the board. Let's get an inductor back on here where it belongs. The little component next to it doesn't look so good. Let's see if we've made any progress before I start replacing everything and going nuts for no reason. So when I plug the charger in, I have a green light. Okay, you can barely see the light because of the damn microscope camera. Whoa, that looks pretty cool. Did you see that? Hey, let's turn the light on. Then off. That looked pretty fucking creepy when there was nothing there but the light. Did you see that? See if I can get it again. Where there's no reflection from the MagSafe. Like the first second, yeah, there you go. Okay, that is pretty cool. Ooh, haunted. Okay, so now obviously I have 3.42 volts because the one-wire circuit, which deals with the charger, is powered off of that, right? So that means that I'm making some progress here. All right, so now let's move on to the next step, which is seeing if the fan spins. Because as I like to joke on this channel all the time, when I see the fan spin, that means we're done. Ooh, okay, so I plug it in. Of course, there's no fan spinning. Like, of course, there's a lot more that's going to be wrong with this piece of shit. So we're going to get the multimeter in voltage mode. We're going to start measuring some things here. Do we have PP bus G3 hot? 12.6? 12.58, close enough. Do we have PP5VS5? That's the 12 volts there. .7. So that area I showed you for PP5VS5 is going to be fucked up as well. So remember, PP5VS3 turns into PP5VSO, which powers things such as fans and everything that runs off of the 5-volt rail. I forget on this machine if the CPU buck converter works off of 5 volts or 12. I don't remember off the top of my head. You can make fun of me and troll me for that later. But one way or the other, no fan spinning, no 5 volts probably, and no 5 volts was indeed confirmed. So let's check out that area and see what we're looking at. Yeah, doesn't that look burnt to shit? Alright. So we're gonna take off a few things here and replace a few things here. So that doesn't fill me with confidence. That's part of the feedback circuit. I went over that in the Lewis Makes MacBook Logic Board Repair Look Easy video. One of those resistors is supposed to be 0 ohms. I would bet my life that those are not 0 ohms. One way to find out, let's measure. Ohms? Whoa, it's 0. So that is supposed to go, this is supposed to be a 0 ohm resistor. So from this side, it's supposed to make its way to this capacitor. Let's see if that board trace is blown, because let's face it, it looks disgusting. I'm impressed. Okay, even though the board is nasty looking and corroded, it's not as destroyed as I thought. Let's check some of these other traces over here that don't look very nice. At 0 ohm. So see, this resistor attaches to this on the chip. This goes through here. So this resistor goes through this on the board. That's a probe point. And you can see it looks like shit. It looks like it's corroded and destroyed, which is why I'm checking those areas. I'm pretty impressed that this is actually working. So anyway, we're going to replace that chip with a new one because, let's face it, that looks like garbage. So let's prep the board a little bit for the new chip. So we solved the first problem, which is no green light and no PP3V42. Second problem is this power supply is missing. You're going to see that I replace a lot of things, maybe just for the hell of it, because I don't like the way they look. Keep in mind that when you buy the boards as cheaply as I do dead, I don't buy dead boards off eBay, by the way. I don't endorse you do either. I buy them. I buy the ones that are missing the CPU and the PCH and all that, but that have all these caps and whatnot here. It's cheap. It really is cheap to replace these things. So if this looks corroded, but it still works, you think I'm going to keep that stuff there? No, absolutely not. Get out of here. Yeah, get off my board. It measured well. I don't care. And this cap too. Like, look at that. That's getting the hell out of here. Alrighty, goodbye. And now on to replacing all this junk. This is my least favorite part of the job. That whole having to have hands that are steady and putting things where they're supposed to go thing. I despise this part. This is not even pretending to melt solder anymore. Come on. That looks like crap, but you'll see how we fix that in a minute. See, this is another part of being a professional, by the way, that I've touched on in a prior video. You know, it's not always about can you kick ass, because a lot of the times you can kick ass and you can do a good job and you can get everything done, just because the stars align and everything kind of works perfectly. But being a professional is, you know, you've had a bad day, your tools stopped working, you had no sleep last night, and you have this ridiculous time constraint, and you've never dealt with this issue before. Like, can you still solve it and kick ass? So, you know, your hot air rework station, which is at the corner of you being able to do your job, decides it's going to stop working. Like, can you still work? Or are you going to give up? Mother. I saw that coming, and I was talking, so I let it happen anyway. See, what I did is I put some flux in the board, and I was just going to heat it and allow all the components to kind of reflow into themselves. But I put the air so high up on this because it's not heating properly that I actually managed to blow the damn thing away. Yeah, again, my point here is, you know, being a professional isn't just about kicking ass once. It's about when the circumstances are not really in your favor and you wind up kicking ass anyway, over and over and over again, and delivering repeatable results. Because realistically speaking, like, you know, client, they don't give a shit that my iron isn't working. They don't give a crap if I didn't get good sleep last night, you know? All they care about is, can I solve their problem? If I can solve their problem, we're going to be best friends. If I can't solve their problem, I am dead to them. That is business. I mean, as mean as it sounds, you know, that is business. Now, nobody cares about your problems. Nobody wants to hear about your problems. And the same thing is true in the workplace. I mean, okay, you're getting a divorce, or oh, you know, you're like your kid has a cold today, and you know he's had a cold for the past week, and blah. And it's not that people are trying to be mean. It's just that everybody else has a kid that's sick at one point. Everybody else has had a sick family member. Everybody else has had, you know, something happen to them. That's why they don't. It's not that they don't care about your problems because they're being mean. It's that they have problems too, but somehow they're working through them, whereas you're just sitting there complaining about them and using them as an excuse for why you can't work. And that's what frustrates people. That's why they don't care about your problems. That's why they don't, you know, they're not crying for you. It's because they have their own problems too, but the world is forcing them to work through it. So, you know, why do I gotta change my life around your problems? You know, why do I have to give a shit that your hot air station is not working the way it used to anymore? Ugh. So if you're in the workplace, just like keep your problems to yourself, you know? Because again, everybody else working there has problems. They're not the same problems as you, but they have problems. But they're not complaining about them all the time because they have, you know, because they know realistically that it's not going to change anything. And they know that other people just don't feel like listening to it, and just awkward, you know, like. Especially since I can't fix most of these problems. I mean, I can't help you with your sick kid. I can't help the fact that your wife is trying to take half of everything you own. I can't, you know, there's nothing that I can really do here. I mean, I could give up my life savings to just give to you, but no, I'm not going to do that. That's why you get those awkward looks from people when you complain about your home and your personal problems at work. Truly, nobody cares. Other people have problems in their life too. Okay, that can get cleaned up later. So, charger. Let's get the charger and let's get the fan and let's see what I have and what I don't. Where's my fan? Most important part of any logic board testing rig is the fan. Because when the fan spins, you are done. Okay, fan still doesn't spin, so let's see what we got, what's missing, what we don't got, and go from there. volts. P bus G3 hot is 12.5. PP5 ES5 is, now it's 5. PP, okay, now where is PP5V S3? Let's see. Score S3. But before, PP5 ES5 wasn't even working. This chip references that so that it knows how to create PP5 ES3. And let's see what I have for PP5 ES3. Five volts. And you still don't want to turn on. .4 volts is there. 12 is there. So now here we get to the other section of this, which is going to make it a nightmare. So see over here where that's the SMC. And that is super corroded crap right by the SMC. See that? That cap and that cap. So we haven't even gotten to, I don't even give a shit about CPU V-core just yet. That's going to be CPU V-core right there. I know that's probably not going to work. Well, we'll fix that later. But this means that water got in the SMC area. And this is the thing. Like, I don't want to drive myself nuts over. And this isn't even for, again, retail. This is for wholesale, which pay less. And doesn't add to client base later. So it's like, it's one of those things where, you know, I'm literally, every single time this one person sends a board in, I go through and repair every single power supply. I go through and you're going to have to fix every single BGA. It's just such a damn nightmare. All right, so I got a keyboard over here, and one of the things I wanted to see is if it would turn on an SMC bypass, which is when you hold the power button down for a while and then plug your charger in. So if I do this, I unplug my charger, I plug my charger in, and I have the keyboard button hit down, it actually winds up turning on. Which means that in addition to every other single issue that I have here, I also have the issue of most likely having a bad SMC, or an SMC that needs a reball or a reflow. When I say that reflowing BGA chips is bullshit, I'm not referring to the SMC. I'm referring to reflowing flip chip designs, like old AMD CPUs, like discrete graphics chips for laptops from NVIDIA and AMD. I'm not talking about water-damaged SMCs. There could just be a ball under that chip that got corroded as a result of water getting under it. The balls under that chip are really, really small, so it's very easy for them to get corroded. Thing is, it's about 10 o'clock, and my gym closes at 11. Do I want to stay? Do I want to sacrifice going to the gym and enjoying myself and getting a meal that I like at the end of it from the place that closes at 11, or just to reball an SMC, whether or not that's even going to work? And the answer to that question is no. So, you know, again, one of the things I talked about in the last video about interns and why I don't have, one of the things that would probably piss off interns is, I know I can solve this board problem. I know I can, but I'm going to choose not to. It's actually not worth the money to me to inconvenience myself and to change my life for a motherboard that may or may not bring me $225. Like, I may do this and it may wind up having a bunch of other issues that I can't fix, and I may not be able to get paid. I'm just at a point in my life where that's just not worth the risk. I mean, you know, it's one of those things where you say you're going to go to the gym every day. You say you're going to see your friends at this point, and you say you're going to go to the gym every day. You say you're going to have lunch with your friends at 3 or 4 or 5 or 6, but you're this far away from making $200. Don't you want to see if it works? Isn't it worth it? And 6, 7 years ago, it was worth it. 17 years ago, it was worth it. Even 2 years ago, it was worth it. At this point in my life, I value my life over this. I do. So this is going back to the bottom of the pile. It is, because so far I've fixed several issues with it. I know there's going to be more. I know once that SMC is done, even if that works, I know I'm going to have backlight and CPU V-core and all this other crap. So this board goes right back in the bin, and I'm going to go on to live my life. So again, what I was talking about in that video was, I know that if I start charging people for education or I start taking on free interns, you're going to expect me to sit and do this rabbit hole board, where I may decide at that point, I want to toss that back into the bin and live my life and come back to it when I feel like it. And that's important. You need to live a happy and healthy life in order to be able to use your brain, in order to be able to see your business clearly, in order to be able to manage your business clearly. You can't just like sit in a little room for 15, 20 hours a day going down rabbit holes all the time and expect that you're going to be mentally healthy. You need to remain mentally healthy in order to learn this stuff. You need to remain mentally healthy in order to see that there's a light at the end of the tunnel, in order to learn, in order to make money, in order to make clear, rational decisions. So I know that there's probably a damn good chance of me fixing it, and I know that if I stayed here all night that I'd figure that out and probably another one, but I'm not. So I'm going to be turning the camera off. If I come back to this one later, I do. If I don't come back to it, you got to see my troubleshooting process for this. I'm going to label this part 1, just in case I wind up coming back to it and doing part 2 when I figure out everything else that's wrong with it. And that's about that for now.